Hi everyone, very excited to see you all, taking some time of your day to come here and enjoy a bit of Kubernetes. Just a little introduction for myself. I'm Victor Zanabria. I'm originally from Peru, but living in Sweden for a couple of years. And I have been working in the world of IT for 8, 9 years more or less, doing different kind of things, developer, business analyst, architect, working a lot with user experience, so different kind of things going on. And this is because I was not actually sure of what is it that I liked, but the only thing that I was sure is that I always wanted to have the big picture, the big perspective of how things work, how components are connected to each other, and how that finally ends up delivering value to the end customer. So when I started to work with Kubernetes more than a year ago, I was a bit unsure how to start going to the documentation. You go to the Kubernetes page and it's just a bunch of theory going on there. Then you go to different blogs and you find the same. So it took me a couple of weeks, 3 weeks maybe, to start putting all the components together and trying to figure out how Kubernetes work from within. And I thought that, well, this should be shared somehow. Like it shouldn't be that difficult for someone that wants to start to just go to a bunch of theory. I know that you guys, or I think I consider myself, it's quite cool to just jump straight to the practice. But it's also good to know how things work from behind as well. And that's what we're going to talk about today. Before starting, how many of you have been working with Kubernetes? Many. How many of you have been working with Kubernetes in production? Okay. How many of you know what is container? All of you? That's super. So I have to kind of skip that part. Let's start to understand where does Kubernetes fits when it comes to computer architectures. So we come from dynamic infrastructure to fully managed infrastructure. Kubernetes is somewhere in the middle between platform as a service and infrastructure as a service. So before you start working on it, you have to realize that there are some things that you will need to manage. So it's not like a complete machine learning as a service or translator service that you don't need to worry about that, but it cares. You need to put some effort on it, on the maintenance, and so on. Before starting, I wanted to talk a bit about the main reason why everyone is here today, which is the pizza. So I was thinking about this when I was preparing the presentation and tried to see how these things are related, and actually there's a lot of things in common. So let's imagine that you guys are a visionary and you have an idea about having a pizza chain, and you want that someone implements that for you. So we're going to talk a bit about that. You need a team in order for you to establish a pizzeria chain. So first of all, you need a CEO, the one that you will just come with a bunch of ideas, a vision, and then he will make sure to execute. Well, he and his team. He cannot do anything by himself, right? First of all, I think the first player, you need to have operations team, the guys that will take care of the things that no one else wants to take care of. Then you need to have an architect, which is the one who will make sure to define where are your stores going to be placed, how it's going to be the design, and so on. Then you need couple of guys, the engineer that is going to make sure to build the stores that the architect designed, and then you have the security guy who will make sure that everything is well, healthy, monitoring, and so on. Then you need to have the communications guy. What is a pizzeria without delivery, right? So you need to have communications between the different pizza stores and also with the people from outside that wants to contact you. And finally, you need to have the assistant or secretary or whoever you want to call it, which is the one who will always take notes from the CEO, every decision he makes. So let's start with the operations team. And they will make sure that the different, let's imagine that we are building this pizza chain from scratch, so you don't have nothing, you will build everything from scratch. So they need to make sure that they are finding the land where you're going to actually build the different pizza stores. All the processes that are required for that, the operations team will make sure to have that in place. And not only that, but a lot of other things as well. And then once this has been done, comes the architect, and he will make sure to say, okay, depending on how big is this area, I will make sure to place one pizza store here, two pizza stores there, and so on. Then we have the pizza store. This one is a quite interesting model. So you can see here, it's kind of weird that you have the kitchen, the storage, and the guys doing the accounting and finances in the same place. A bit messy, but possible. And of course, the guy that is going to build this and the guy that is going to monitor this are there. You can have different models of how you want to make your pizza stores. First of all, you can have only one kitchen in one pizza store, which makes more sense, and separate the accountant, finance, and the storage somewhere else. It could be that if you have a burning or a fire in the store, you mess up with all the things that you don't want to. So better to separate things. It looks a bit better. Or if you want to be a bit more fancy, you want to have the storage in the cloud, have a fully completely separate finance accountability area, and just the kitchen, so that you focus on the business completely separate from all the other departments. And finally, you need the communications guide to just allow communications between people from outside and communications between the different pizza stores. And in this case, what we are going to use, I know that right nowadays you have an app and you just order your pizza there. But in this case, let's imagine that we're a bit traditional. So we have telephone numbers, and that's going to be the way how we're going to communicate ourselves. So how is this related to Kubernetes, actually? I promise that there is some relationship. So Kubernetes, well, there is somehow the shape, right? More or less. More or less. So when we talk about Kubernetes, we talk about two different categories. First of all, we have the Kubernetes cluster. When you deploy Kubernetes, what you get is a cluster. And then afterwards, you get Kubernetes Objects, which is the things that people usually work with in most cases. Let's start with the first one, which is the Kubernetes cluster. When it comes to the Kubernetes cluster, there are two things that you get with it: the master node and one or more work nodes. And these nodes are nothing else but just, it could be virtual machines, it could be real machines, it could be your cell phone even. So, but for this specific example, let's say that a node is a virtual machine, but it could be something different as well. So you start with the master node, which have four components. These are the main ones. And then you have work node, which has two components, the main ones again. This is quite flexible, by the way. If you want, you can change these kind of things, but Kubernetes already provide that from the beginning. So the Kube API server will be your the CIO that we saw before, CEO, sorry. The etcd is like the assistant that takes notes of every decision that the CEO makes. The Kube scheduler is like the guy, the architect, that will make sure to place the different, we will see pods afterwards in the different places depending on the characteristics. And the Kube controller manager is the operations team that will do all the bunch of things that we don't see behind the scenes. When it comes to worker node level, the kubelet is like a mix between our civil engineer and our security guy. He will make sure to build and monitor at the worker node level. And the QProxy is like our communications guy. He will make sure that communications go across the different worker nodes and so on. We will take a look at that as well. When it comes to Kubernetes objects that I mentioned before, there are like many kinds of Kubernetes objects, and you guys will be interacting with them once you get deep into the tool. Here I just mentioned 5, but there are more than 30, 40, maybe even more. But yeah, we cannot cover all of them in one single session, so I just thought to cover the ones that I think are enough to start. The nodes are like the piece of land that we say that we're going to place our pizza stores. So depending on the characteristics of the node, which means resources like RAM, memory, different kind of things, you will be able to place different kind of things. The pods are like our pizza stores. Again, you could have different things inside the pods, and we're going to take a look at that later as well. The services are like our phone numbers, the phone numbers of the stores. Thanks to the services, you will be able to communicate with each pod, between pods, and with the outside world as well. Volumes is like storage, but again, this is like a physical storage. So maybe it's not something that you want to use nowadays. It's not persistent. It could be lost, it could be burned. So you gotta be careful with that. We're going to take a look at that as well. The persistent volumes is something a bit much more secure than the normal volumes. Also used for persistence. It's a bit more persistent, as its name says. Okay, so let's start with Kubernetes objects. It's a little water break. So let's start with the pod. When I started to work, when I was starting to do the research of pods, I saw in many places that they say, oh, a pod is a container. And that, when I started to work, I realized that that was not actually the case. And many people think that a pod is a container, but actually it is not like that. As you can see in the pizza store, you can have different kind of things inside one pizza store. In the same way, when you have a pod, you can have different kind of components. You can have one container, two containers, a volume, etc. You can define how you want your pod to be. However, as you could see in the image, if you have all the things together in one single store, it could be a bit messy, and you will have to worry about more things than just focusing in one single thing. So that's why most of the people relate one pod with one container, which is kind of a best practice, but it doesn't mean that you only can have one container in a pod. When it comes to a node, as I explained before, the node is the place where you're going to put the different pods, like the LAN where you put different pizza stores. So you could have, again, one pod, two pods, three pods, depending on the characteristics of your node, depending on how many resources you have there, you will be able to place as many pods as possible. And these are two attributes, well, label is attribute of the pod, and of course I have been writing down the port, which is the mean on how you're going to communicate with the container. A service. So the service is again like a telephone number. It will help you to have the communication between pods. However, when you want to call a friend, you don't type the telephone number every time that you want to call someone, but you actually just look or search for their names. In the same way, pods, they don't know what is the IP of the other pod in the other virtual machine. They just know that there is a name that links to that. In this case, it will be the Italian pod, making Italian pizza. So when he wants to get in touch with Italian pod, he will not know at all if he has an IP or whatever. He will just say, okay, service, I just want you to please call the Italian pod. However, it doesn't matter how. He will make sure it doesn't matter if the pod is here, if the pod is in this node, or if the pod is even in this node. He will not know that. That's one of the cool things of that service, that you don't have to worry about that networking thing when you're working with that. Kubernetes volume, as I explained before, you can have a volume inside a pod, and actually it's for storing some information, storing data, but unfortunately it's not persistent. It could happen that the container can die, and then it's fine, your volume is still alive. Another container is created, you point to that specific volume, and you still have some functionality working on. But pods are not persistent, so if a pod die, the information that you stored will also disappear. So you run with that risk. If you want to work with data, the specific information that you want to save in a persistent way, don't use volumes, please. Otherwise, you will end up losing important information. And that's the reason of persistent volumes. Persistent volumes are more persistent. The difference with the volume is, as you can see here, the persistent volume lives outside the pod. And depending where is it that you are running your Kubernetes cluster, it could be on-prem or it could be on cloud. You can define different ways of storing your information. Mostly if it's in cloud, you have different kind of storage classes. In AWS has one kind of storage class, Google Cloud, another kind of storage class, Azure, and so on. And that will allow you to save information in a persistent way. So here the container die, nothing happened, the pod die, another pod gets created, the container is up and running, and your information will be there. So this is not attached nor to your pod or to the node. Okay, so those are some of the Kubernetes objects that I think are the most important and the ones that you actually need to understand to start working with Kubernetes. That there's also one that you use a lot for production, which is the deployments, one kind of Kubernetes object. I haven't put in this slide today because I would have to cover a lot of topics, but I think if you know the concept of a pod and understanding what a deployment is, it will be quite straightforward. Okay, now we are going to talk about the things that no one's talking about, something that no one talk about when they start working with Kubernetes. They just focus about the Kubernetes objects that we saw, but no one actually, or few people actually gets deep into how Kubernetes work from within. There are so many things that we assume that Kubernetes will do for us, but actually how Kubernetes does it is through these 5 components. There is one that is missing, that is the etcd, the assistant, but we're going to take a look at that soon. So the Kube API server, what happened with the Kube API server is that he will make sure to just receive your desires. You, as a user, you will drop a lot of desires to Kube API server. I desire to have a pod with the following characteristics. I desire to have a service with the following characteristics, and so on. You will just drop a lot of desires regarding Kubernetes objects that you want to have in your Kubernetes cluster. And Kube API server will make your desires come reality. For this, there are 2 ways of doing it. You have a declarative way and an imperative way. The imperative way, it's almost what you do when you're doing bash, when you're going to the command line and specifying task by task. The declarative way is that you just specify your desires to Kube API server. You don't have to specify step by step what is it that you want, and Kube API server will handle that for you, which is is the most common approach to work with Kubernetes. And here you have the etcd that is always there, taking notes of what Kube API server does. So that's Kube API server. When it comes to Kube Controller Manager, I want you to see very well this image, this icon, and keep it in your mind. So the controller manager, as we saw before, the Kube API server will get a lot of desires, and he will have a lot of things, but he will not be able to make these things come through by himself. He needs Kube Controller Manager, and the name says it's controller manager, so he cannot do things by himself a lot. He needs people to do things. So he has different kind of controllers behind him. It could be that he has deployment controller, which is the controller in charge to create deployments, namespace controller, the same, node, ingress, and so on, and so on, and so on. There are many kinds of controllers that are in charge of doing one specific thing. And the Kube Controller Manager is always watching when you as a user come to the Kube API server with a desire of creating a Kubernetes object. Kube Controller Manager will be there watching all the time to make sure that all your desires are actually running in the background. So what happens is that you have the node controller, and then the order comes from API server. Kube Controller Manager is watching, the node controller gets activated, and it creates a node, or it creates two nodes. Then if you actually came to Kube API server with the desire of having one Ingress object, Kube Controller Manager is watching, the Ingress controller starts working, and one Ingress object is created, and so on, and so on, and so on. With all the different kind of Kubernetes objects that you have, there's one controller that will be behind the scenes doing all the dirty work. And that's the controller manager. Now the Kube scheduler. As we said before, the scheduler is our architect. What will happen is that you will come again with a desire to have a pod with ABC characteristics. They will come to the Kube API server, the Kube scheduler, the same way that the controller manager. It will be watching all the time what's going on Kube API server. Then Kube API server will say, okay, there is one pod that needs to be created, and the scheduler, what he'll do is that he will check all the different nodes that are working right now and say, okay, the new pod will be created in this specific node. He will not create the pod. He will just say, as an architect, he will just put in the design on paper, or well, on the computer, where is the pod going to be placed, but he will not be actually the one creating that pod. So he will just decide where to place it. So now, how things comes through is on the worker node level. So what happened is that when the pod was already placed in one specific node by the scheduler in the previous step, we need to create it. Now we design it, now we need to create it. So this kubelet is watching that the scheduler has been placing a new pod in the node number 1. The kubelet will come and he will call the container runtime. For here I have to, so I think that most of you have been working with Docker, but Kubernetes can work with all the other container runtimes. So you have container, CRIO, which are the most popular container runtimes that Kubernetes work with. So if you guys have interest of working with other things than Docker, you can have it in Kubernetes. But what will happen is that the kubelet will make sure that the container that is specified in the specifications of that pod, it's up and running. And not only that, but he will make sure that those containers are actually working correctly, that they are healthy, and monitoring that nothing wrong is going on with the containers. In case that one container goes down, the kubelet will make sure that that container is created again. And finally, we have the QProxy. So what happened with the QProxy, again, QProxy is watching the Kube API server. And for instance, we have right now this structure, this setup, when one pod is communicating from one node to another node. Let's say that the store where they produce Hawaiian pizza wants to call the Italian pizza to produce more pizza or something like that. This could be different kind of applications you could have, an API for getting the number of pizzas delivered today, another API, or whatever you want to have, depending on what is the purpose of your container. And again, they are just communicating to each other by the name. They don't know their IPs. However, what happens when one container dies or one pod dies, then it could be that the QProxy is watching that something wrong is going on there. Suddenly, the pod number one cannot get in touch with the other one. So when this happens, then again the kubelet and the kube scheduler will work to create the pod that just was destroyed a few minutes ago, a few seconds ago, and they will come to a solution. Okay, we are going to create a new node. We are going to design to place that pod there, and suddenly the kubelet will make sure that the container is up and running. And when this happens, it's like, okay, now it's super cool, but this is somewhere else. This is not the virtual machine, not the same virtual machine. This have another different IP. How can he know that he has been created? So there is where the QProxy comes into the game, and actually he will make sure that every networking configuration that needs to be done so that this pod can still get in touch with this pod without doing any change in code or anything will happen behind the scenes, and you will not even notice. So here we are talking about a very potential tool when it comes to networking that Kubernetes is providing, so that you actually don't have to worry at all about the configuration of the networking, because no matter what happens, the QProxy will make sure that your services are still up, running, and talking to each other without you basically doing anything. So I think this is a sequence diagram that I think most of you must be familiar with. Sequence diagrams. It's just basically to explain the life of a pod, right? And you create a pod, the API server, etcd writes, it's notified the API server, then the scheduler is watching all the time, that then he will know that one pod needs to be created, so the scheduler will actually do the binding. Again, the API server will get notified, etcd will take notes, the kubelet will be watching all this process all the time, and he will know that a pod has been bound to one specific node. He will call the container runtime in the background, and Docker or whatever the container runtime is will make sure to put the containers up and running. Finally, kubelet will come back to the API server and to just update the pod status, and etcd will take note of every single thing as usual. So that's when it comes to the creation of a pod, and this is just for one Kubernetes object. The flow varies for different kind of things that you want to create. If you want to create a new node or a new ingress, things will be different. But more or less here you can see how the different components inside the master node talks to each other. So now we're talking about networks, how network work in Kubernetes. It's very important. It's one of the most important things in Kubernetes to understand how all this communication is possible and what is it that you can do to communicate your different components and services. Ingress, it's not a service. I consider it as a service because it works as a service, but it has its own kind. But that's why I just put it in different color. So the services, as we saw before, they are the ones in charge of communication. but not all the services are the same. There are these three kinds, the most important ones. This is very useful as well. So the first one is a service with the kind cluster IP. So cluster IP will make sure that different pods talk to each other, and this is in the internal setup. In a microservice architecture, let's say that you have to orchestrate different services or different APIs from within that you don't want to expose to the outside world. So cluster IP will be there, making sure that your different containers, the different pods that are working in a very specified function, talk to each other. And again, he will do that just providing few lines of code and providing few attributes, and he will make sure that all the communications between the different pods is done correctly. So what happened is, again, if one pod dies, nothing happened. He will not notice. A new pod is created, and he will just needs to know that there is a service that will provide some specific information, but actually the one who provides the resources is the pod that is behind. Then we have node port, is second kind of service. So okay, everything was cool with the cluster IP. You have communications between the different components in your microservice architecture, but you also need to talk to the outside world. You need to make sure that the users are getting access to your services. So with the node port, you can do that. What happens is that a port is open in the different nodes, and finally your users, when they want to actually access to your service in one specific pod, they will access through a port in your virtual machine. This works, but it's a bit ugly. So you have one user in mobile that have to point to one public IP, one port, but if they are accessed from a desktop, they will point to another public IP, and it could be the same port or another port. So this works, but it's super ugly. You usually use that for development purposes, where you only have one node, so that you test the connection if your pods are actually taking some information from the outside world, but it's not at all recommended for production. Then we have the load balancers. Things starts to get a bit nicer when it comes to load balancers. So the difference with the node port is that actually with the load balancer, you don't have to worry about the ports that you are going to touch in the different nodes. But you place a node balancer before the service, and then afterward the service will make sure to talk to the different pods in the different nodes. However, as you can realize here, this pod is the same. It's like a replica of the other one. And this happened because one service, usually, not all the time, but most of the cases, the service is pointing to one specific pod because you are assigning. Otherwise, it could be that you are calling someone, but then the number sometimes is for you, and then sometimes works for someone else. You can somehow do it, but it's not recommendable. So usually it's one service linked to one specific pod. But of course, if the pod is the same, they have replica, it's fine. There is no problem there. But if you would have another pod that is not a replica of this one, but is a pod that is in charge of doing another different thing, then you will need to create a new service. And there's where we have a problem. Here you solve the problem of the ports. Here it will be transparent for the end user to call your different services, but there is one problem here. That is okay. So what happens is that if you have in one pod one container in charge of having the Malmo DevOps web application, and in the other pod you have a container in charge of doing the Malmo DevOps API, those are two different kind of things that will be exposed to the outside world. So for the first one, you will need to have a load balancer that points to a service, and that service will point to the specific pod. But for the other one, you will have to create another service which will need another load balancer. So here we are talking about two node balancers, and if you would have more services that you want to expose to the outside world, you will need to put as many load balancers as services that you want to expose. And this is completely possible, but it's expensive, especially if you're working on cloud. Load balancers are mostly for Kubernetes and cloud. That can be very expensive and also a bit difficult to maintain. AWS have one kind of functionality when it comes to load balancer that allows to have one single load balancer pointing to different services, but our friends of AWS, they like to build solutions that works only in AWS, and Kubernetes is cloud agnostic, so it doesn't work very well with this specific thing that AWS have been working with. I don't remember the name right now. And that's why we have Ingress. With Ingress, things starts to get a bit more interesting. So you have one extra layer between the load balancer and your service. So that extra layer, which is the Ingress, will actually allow you to have as many services as you want with only one single load balancer. It's quite nice, actually. He will make sure that if you are sending information or you are actually requesting information from this specific service, it will go through him. He will make all the networking stuff behind the scenes with one single load balancer and so on. And this could be applied for multiple environments. You could even have two different services, one for each environment, and you don't need to have two different load balancers. You can do it with only one single load balancer, unless that you have a lot of traffic and then you want to put more than one load balancer and so on. So this is the cool thing about the Ingress. It's actually quite nice when you work with that. I really enjoy that part. So yeah, and that's basically it.